Hello everyone, my name is Kasturi Basu. I am a data science and business analytics intern at the Sparks Foundation. This is my first task, prediction using supervised machine learning. In this task, we are going to predict the percentage score of a student based on the numbers of hours studied using simple linear regression. In this task, we have two variables where the feature is the number of hours studied and the target variable is the percentage score. Further, we will predict the score of a student if she or he has studied 9.25 hours a day. This can be solved using simple linear regression because there is only two variables. Now, the next step has to be importing necessary libraries. We have imported NumPy, which is for scientific computing. Secondly, Pandas, which provides data structure and operations used for data manipulation and analysis. We have imported Matplotlib and Seaborn for data visualization. And last but not the least, sklearn, which is the abbreviation for scikit-learn, which is used for machine learning. Library is imported successfully. Now, after getting done with this step, we are going to move on to the next step, which is reading given data from remote URL. I've saved the URL as an object named URL and then read the data from the URL with help of pandas library by using the read_csv method. Data imported successfully. Now we're going to explore the given data. Firstly, I have printed the first 10 rows of the data set using the head method. I've put the argument 10 because I wanted to put 10 rows from the data. If I had put nothing as the argument, then it would have showed 5 rows only because that is the default for head method. Now I have checked the shape of the data with help of data.shape. The shape of the given data is 25:2, that is there are 25 rows and 2 columns. I've digged deeper into the data set with the .describe method. Now I've included all. This is a good practice to use include all. In this case, I will not be able to understand any difference because I have only two variables, which both of them are numeric type. Here I can show you. Control X for cutting the part and run. See, there's no difference. Control V, paste. But once we have more number of variables, or maybe variables where there are object type of variables or numeric sort of variables, then this will be extremely helpful to know about all of the variables properly. Here we see that 25 is the count for both the variables, that is there are 25 rows each. This is the minimum of both the variables. This is the standard deviation, minimum value, maximum value, first percentile, second percentile and third percentile. Now we are going to use info method. We see that there are 25 ordinal values for hours and 25 ordinal values for scores, which means that there is no missing value. So we don't need to handle them exclusively. The next extremely important step has to be detecting outliers, because having outliers in our data set can adversely affect our findings. So we have to make sure that we do not have any sort of outliers, and even if we have, then we need to remove them or do something about them. Now I have stored the data attributes as individual series to plot them individually. Firstly, I have used boxplot for hours data. Now boxplot is a good way of checking if there is any outlier or not. It is evident that there is no outlier in the hours data. Next, I'm going to check the scores data. Here again, I see there's not only just me, every one of us can see that there is no outlier present. So I can conclude that the data does not have any outlier, so we are good to go. Otherwise we would have to do procedures to remove them. Now I have used scatter diagram to know about the data more. Here, this is the output. Now from the scatter diagram I see that there is a fairly positive linear correlation, which is pretty much strong positive correlation among hours studied and scores obtained. This means if the hours of studied increases, the scores will also increase. Now we are going to validate our findings from the scatter diagram. We have used the Pearson method of correlation firstly. Now this is our finding. The correlation coefficient is 0.976 for Pearson method, and this is the heat map to show our finding. Now here this has shown that 0.97 because the value is 0.976, so we can round it off to 0.98, which is a fairly good correlation because this is almost nearly 1. Next we have checked the correlation coefficient due to Spearman. Even in this case also the score is 0.9. The correlation coefficient among scores and hours is 0.97, which is again a fairly good correlation. So we conclude that there is a strong positive linear correlation between scores obtained and hours studied. Next, we are going to prepare the data for further analysis, or that is the machine learning part. Now, after preparing the data, we have split the data or divided the data into training and testing part. The data is divided into 75% training data and 25% test data. The next part has to be training model. Here I have trained the model and print the training completed so that I can be sure that training has been completed properly. It's just to make myself satisfied, nothing more. You could have skipped on this part also if you didn't want to print this way. The next part is fitting the regression line. Here in linear regression, what scikit-learn or sklearn does under the hood is that it finds a line, rather it finds the slope and intercept of the line where nearly all the points fall. But from the scatter diagram it is pretty much evident that there cannot be any such line. So what it does is that it finds a line in which the sum of the difference of the predicted values on the line and the actual values, that is the points, is minimum. And these are our output, that is m is the regression coefficient, which is the slope of the line, and c is the intercept of the line. Now we are going to compare the target value or the actual data and the predicted data. I've just print the x and y part, that is the test x and the predicted y part, just to make sure that everything is fine. Or maybe you could have just skipped this part because it is not necessary to just make it print. I just did it for my satisfaction. The next step has to be storing the actual score and predicted score as a data frame. Now we can see that the scores are pretty much similar, like pretty much same. 20 and 16.8 is nearly same. So we just made a plot, the line plot, to check the difference of actual score and the predicted score. Even in here also we see that there's not such huge difference between the actual and predicted score, so we are happy with our findings. Now we are going to move on to the model evaluation part. We will evaluate the model by two performance metrics for the model evaluation, which are mean absolute error and R2 square score, which is R square score, I should rather say. Now the mean absolute error score is 4.1308, which is extremely small, which means the error is less likely to happen while the prediction. And R2 score or the R square score is 0.936, which is nearly 1, which tells us that our prediction is very precise, because big R2 score means better prediction. So we are kind of happy with our model. So now we are going to answer the question, what would be the predicted score if a student studies 9.25 hours a day. So the answer is, if a student studies for 9.25 hours a day, she or he will score 93.89% in the exam. So thank you so much for staying in. If you have liked the video, then please hit on the like button